Hello, Algebra 1 students. I'm about to do lesson 1-5, solving inequalities in one variable. And before we get on to the opener, I want to just share with you inequalities and what they mean. Write this at the top. We're on page 17 of your note taker. If you're following along in your textbook, we're on page 30. All right, there are 4 inequalities. First one is this symbol. Looks like the letter L, and it stands for less than. If you put a little underline underneath it, it's less than or equal to. In the other direction, we have greater than. And of course, if you put a little underline underneath there, it means greater than or equal to. I think we're ready. Hopefully, most of you have seen these symbols before in your previous math class. Here we go. Skylar competes in the high jump event at her school. She hopes to tie or break some records at the next meet. In the diagram, the state record listed as 1.75 meters, district record is 1.57 meters, and her personal best is 1.48 meters. A meter is a little more than 3 feet, if you're kind of wondering that. Question. Write and solve an equation to find x, the number of meters Skylar must add to her personal best to tie the district record. All right, let's do that. Her personal record is 1.48. We need to add how much more she needs to beat the district record, which is exactly 1.57. X, of course, is the variable, and we're trying to solve it. And don't forget about order of operations backwards. Please excuse my dear Aunt Sally. And we are going backwards when we're solving. Okay. So we're going to go ahead and subtract 1.48 to both sides. Pretty easy. Line up the decimal points, and it looks like we need 0.09 meters. Great. Let's move on to the next question. All right, rewrite your equation as an inequality to represent the situation where Skylar breaks the district record. Break sounds like more than. How is the value of x in the inequality related to the value of x in the equation? All right, let's set this up. I guess your interpretation of break could be tying it or go past it. We're just going to be, you know what? We're just going to keep it at breaking it then. There we go. The order of operations is the same. Subtract 1.48 to both sides. And she needs to have more than 0.09 meters. How many meters does Skylar need to add to her personal best to break the state record? Well, instead of 1.48, it's now going to be added to an unknown amount, we're going to change out 1.57 with 1.75. That is the difference. Solve that one. And we'll get 0.27 meters. Perfect. Anything greater than 0.27 meters, Skylar will break the state record. All right, we're going to skip this question at the bottom there. Any questions? Let's move on to the next section, next page, I mean. All right. All right, a couple of things we're going to put here in addition to solving. I just wrote this down a moment ago. I'm going to write this down again to just, nice review, nice reminder. Solving goes backwards of order of operations. Something to keep in mind when it comes to inequalities. If you multiply or divide by a negative number, then switch the inequality. Something to keep in mind. You can actually do a quick test. You all agree that 7 is greater than 5. What would happen if you multiply both sides by negative 1? Well, the problem now becomes negative 7. Is it greater than negative 5? No. It is now less than. Okay, there's your switch. All right. We're asked to solve and graph each inequality in one variable. Some reminders about which way to shade. This is, of course, less than. When you graph it, it's an open circle to the left. You follow the arrow. If your inequality is less than or equal to, it looks like this. Closed circle to the left. And let's go in the other direction, greater than, open circle to the right. And one more, greater than or equal to, we have a closed circle to the right. Keep that in mind when we're actually going to go ahead and graph these things. All right, let's tackle example 1. Got some stuff ready to go here. The variable is x. We have an inequality. Let's go ahead and distribute, because I don't want to divide by negative 3 into 10. That's going to give me a fraction. So that's my first thought. Distribute the negative 3. Negative 3 times 2x is negative 6x. Negative 3 times 2 is minus 6. Great. We're going to solve this like a regular equation, but in this case, we've got to watch out for that inequality symbol. Remember, if you ever multiply or divide by a negative number, you will switch the direction of that inequality. Let's add 6 to both sides. That's the first priority. That leaves with negative 6x on one side is less than 16 on the other side. And let's go ahead and divide by negative 6. Oh no! Warning, this is a negative number, negative 6. So that means that inequality is going to switch directions. It's no longer less than, it's now going to become greater than. 16 over negative 6 reduces by 2. And a positive divided by a negative is a negative. Negative 8/3 is kind of hard to visualize on an underline. We can always change it into a mixed number. 3 goes into 8, negative 2 times the remainder of 2/3. Okay, there they are. We are asked to graph it as well. Don't forget about that. Negative 2 and 2/3 is to the left of 0. And we're looking at right there. Yes. Now, the inequality is greater than, which means it's going to be an open circle at negative 2 and 2/3, right there. And you follow the arrow. It's going to be greater than, okay? And it goes to the right. Sometimes you might see the graph with parentheses or brackets. I just want to show you that too. The parentheses means open. Something that I'm going to throw in so you guys get kind of used to it. Whether it's an open circle or parentheses, they mean the same thing. Next one. I have a multiplier, a distributive property again. I don't want to divide by 2. That's going to create a fraction. Okay. 2 times 4 is 8. 2 times negative 2x is minus 4x. Undo operations and solve. Variable is x. 4 is multiplying with it. We don't want to deal with that. 8, however, has a little fancy positive sign in front. I'm going to go subtract 8 to both sides. Negative 4x is greater than, now be careful here, 1 minus 8 is opposite sign, subtract, carry the sign. 7, and the sign is attached to the bigger number is negative. All right, next step, divide by negative 4. Uh-oh, warning, we're dividing by a negative number. Which means we do need to switch the sign. A negative divided by a negative is a positive 7/4. And when you convert it to a mixed number, it's going to be 1 3/4. Open circle still, interesting. But this time it's going to the left. 1 3/4, okay, 0, 1, 2, and 3/4 is right there. It's an open circle to the left. Okay, parentheses again. This is the same type of error, but with parentheses. Any questions about example 1A, 1B? All right. Let's jump to example 2. Here we go. Now, I didn't want to jump into something like this before I represent what would happen if your variable is on the wrong side. Let's say we have like 3 is less than x. You don't say it that way. You normally say it x is first. Here's the weird part. Like a mirror image, if you exchange the 3 and the x, the symbol also changes direction. So this is another case where when you swap quantities, you also change the direction of the inequality. Okay, just want to make sure you guys know that. All right. Example 2 in the note taker. Solve 2x minus 5 is less than 5x minus 22. All right. Couple of opportunities here. You can move the 2x over to the other side, but eventually you're going to have to move that x to the left-hand side. Or you can subtract 5x to both sides and deal with the negative sign last. It's actually up to you. Let's go ahead and, because we're learning about the swap business, let's go ahead and move the 2x to the other side. We're combining like terms across the inequality, which means we have to do opposite operation. 5x minus 2x is 3x. Great. Let's go ahead and move everything from x, the variable. I'm going to go ahead and add 22 to both sides. Watch out for those negatives. 22 minus 5 is 17, is less than 3x. Divide by 3 to both sides. Those leading coefficients go away. 17/3 is less than x. We don't say it that way though. You want to swap the order of how you say it, but that means the inequality changes direction as well, okay? That's a swap, which means the inequality changes direction as well. Let's graph it on the number line. 17/3 as a mixed number is 5 2/3, I believe. Yes, it is. 5 2/3 is over here somewhere. We're just going to eyeball it. Yeah. Open circle to the right. Follow the arrow. And don't forget, the other way is just using parentheses. Just want to let you know, if we had to graph something with an equal sign, let's change this. 3 is less than or equal to x. X is greater than or equal to x. 3, I'm sorry. Let's go ahead and just see how that looks with graphing. At 3, close circle, and to the right. Using the other symbol, we use something called a bracket to the right, okay, to represent a closed circle. All right, next page, example 3, yay. Doing great on time today. These are going much faster than some of my previous ones. All right, this is a case where we have a couple of weird incidents with, in fact, infinitely many or no solutions, okay? All right, let's solve it like regular, like we did in the last examples. Let's do that. Distribute the -2 to both sides. I'm sorry, distribute the -2 to the parentheses. That's what I meant to say. -2 times 4x is -8x. -2 times negative is +4. -8x on both sides. What happens when we add 8x to both sides? Oh. They go away. The variables go away. We're left with 4 is less than 4. Now be careful. Here we do have variables disappear. But the inequality may seem at first to be true, but it is false. There's no solution. Nothing would ever make that true, okay? Over here on the other side, distribute the -3. Let's see what we get. Negative 3 times 2x is negative 6x. Negative 3 times 1 is minus 3. If you add 6x to both sides to try to combine them together, they both disappear, leaving with a negative 5 is less than negative 3. Yeah, negative 5 is less than negative 3. This is true. Definitely true. In fact, no matter what you plug in, it'll all be true. Infinite solutions. So just a basic reminder about variables disappearing. We have no solution and infinite solutions again. Let's switch to the last page. We're going to skip example 4. That's not necessary. All right, I'm going to crank through these ones on the last page. Starting with number 5. I'm going to zoom in a little bit so you can see. There, much better. All right, this is a great opportunity to deal with fractions. That 1/2 x, there's a way to get rid of that 1/2 in one step, and that is to multiply by the reciprocal. And that happens to be 2/1. Okay. The 2's go away in the left side, leaving with an x is less than 12. And they want us to graph it. Fine, let's do it. Let's open circle at 12. And it's follow the arrow time less than. Okay. Another way to represent that, of course, is using parentheses going that way. Same thing right there. Okay. On the number line. Number 6. Negative 4x is greater than or equal to 20. I have a feeling that we're going to be flipping the symbol because when we divide by negative 4 to both sides, that's a red flag. That's a negative number. We're going to switch the sign, okay? Bam. X is now going to be less than or equal to positive 20 divided by negative 4 is negative 5. Let's graph that. Negative numbers are to the left. Close circle this time. And this time it goes to the left. Actually, they both went to the left. Because it's closed, it's a bracket and with an arrow going to that direction. Number 7 is next. Distribute the negative 4. Now be careful. Distributing a negative 4 doesn't mean you're multiplying by negative 4 to both sides as a new operation. You don't change the inequality until you actually go. This gives us on the left-hand side 8. And on the right-hand side, we have negative 4x plus 4. The rest is undoing operations. Subtract 4 to both sides. This is the last step. Divide through by negative 4. Or is it? 4 divided by negative 4 is negative 1. And because we're dividing by a negative number, don't I have to switch the direction of the inequality? I certainly do. Here's the other crazy thing. We don't read that backwards, do we? So we're going to do a little swap. Let's do it. X is now going to be less than or equal to negative 1. There's your answer. Let's graph it. There's my 0. There's my negative 1. Close circle. Shade to the left. Okay? It's a bracket as well. That means the same thing. Let's go on to number 8. All right. What happens if we add 3 to x to both sides? Oh, I was expecting one of those weird cases, but we got 6x minus 2 is greater than 4. Add 2 to both sides. Oh, almost done. I can feel it. 6x is greater than 6 divided by 6. This is great. X is greater than 1. Open circle to the right. Okay. Open circle to the right. Parentheses. Woo! Not too bad. What do you guys think? All right, that's it. That takes care of another section. Thank you very much. Have a good day.